Now we consider the question of how much work does the net force do in this case? How much work does the net force do, and how much force does the applied force do? The applied force being this horizontal force. How much work does each force do in 3 seconds if we start from rest? Well, what do we know? Now I've written this up on the board, but I'm going to kind of insert it here because I want to do this systematically and see how it develops. So what do we know? Well, we've calculated the acceleration. I've given you the 3-second time interval, that's delta t, and the initial velocity, which is v naught. We know the mass of the object, and we know the applied force, which is the horizontal force, which is the 60 newtons in this case. Okay, so how do we put these together into an answer to the question, how much work is done in 3 seconds by the various forces? Well, first place, we want to see how far the thing goes, because we want to know what displacement to use along with our force to calculate the work. So we take the acceleration and the delta t, we get our delta v, change in velocity. Okay, we put our change in velocity together with our initial velocity, we get our final velocity. And of course then we can put our initial and final velocities together to get our average velocity, which we can then multiply by delta t, which is going to have to kind of snake through here, to combine with the final velocity to give us our displacement. Okay, so, well, at this stage, we can put our displacement together with our applied force and figure out how much work is done by that force. So here we have, which I'll call delta W APP for applied. Now what else can we do? Well, we have the mass and we have the acceleration, so we can get our net force. And we can put the net force together with our displacement to get the work done by the net force. All very straightforward. Well, you would need, and I would recommend that you be able to write down the symbols for the things that you know at the beginning of this problem and work through how to put them together in your own way. You don't want to list them the same order I did. Your diagram's going to look different. And do the calculations. See what you get. Okay, so that's how you're going to approach that particular problem. And I will say that, I set it over here, I drew another diagram, pretty much with everything in the same order, because I was kind of looking at it, and I don't know why, but I was. You get your work done by the net force, your work done by the applied force, and I say they ain't the same unless F, little f, is 0, little f being the friction. Because if the friction isn't 0, then the net force and the applied force that you need to, well, the applied force that you get are going to be different for reasons that should be very obvious. So these, I say, ain't the same unless F equals 0, which it ain't. Little f, frictional force. Frictional force is not 0. Work by the net force, work by the applied force are going to be different. And you want to ponder that.